So radians and degrees are two ways of measuring the rotation in a circle. And you are very, very used to using degrees, and I'm just about to introduce radians to you. What's the point, though? What's the point? Well, the point is that there's actually no real reason for why there's 360 degrees in a circle, or at least there's no real mathematical reason. There's plenty of sort of social and cultural reasons. Ancient Greeks liked it, or the ancient Romans, I can't remember which ones it was, liked it because it was roughly the days in the year, and the ancient Indians, it was a religious number to them. But actually, there's no real reason for it. There's no mathematical understanding for it. So we need a mathematical way of representing the rotation in a circle. And most of mathematics links into other areas of it. So obviously we're talking about circles here, so why not link the rotation of a circle to other features of the circle? And that's precisely what we're going to do. So most of the other features of the circle link to its radius. So let's do that. Let's take the length of the radius, r, and spread it out around the circumference of the circle. So the amount we've measured around the circumference of the circle is the same as the length of the radius. And that angle there, we're going to call 1 radian. Now if we go around again, then the angle from that initial radius line all the way around will be 2 radians, if that's the length r. And then we get 3 radians, and we actually get 3 and a smidge, well, it's a smidge radians in a semicircle. In fact, it's 3.1415, so on and so forth, radians in 180 degrees. And actually, that's pi. It's pi radians in 180 degrees, which sort of makes sense, right? Because we know that the circumference is 2 lots of pi r, and we're doing half of that, so that's 2, or rather, let's try that again. That's pi r, pi lengths of the radius. Now, if each time we go the radius length around the circle, we end up with a radian, then we end up with pi radians at the end too. So 180 degrees is pi radians, and we represent radians with a little c. So a whole circle then, a complete revolution of the circle will be 2 pi. And really, that's all you need to know. The last thing just to think about then is if we've got an angle that, say, isn't very obvious, how do we convert it into radians? Well, I know I could work out what the fraction of 42 is out of 180. So how much of a semicircle is that angle? And then I know that a semicircle is pi radians. So let's multiply that by pi. And that would give us our answer. So here I could cancel down by 2. That would give me 21 over 90. Still not particularly nice, but it's 21 pi over 90. So for some of our key angles then, say for instance 60 degrees, 60 of 180 times by pi is a third of pi, so it's pi by 3. And 45 of 180, well that's a quarter, so it must be a quarter pi radians. So some of them have really nice ones. And now anything you've ever done in degrees, you can now do in radians. And so things like our sine graphs and cosine graphs, all of those work for radians as well. You must be very, very careful then that your calculator is in the right mode, because your calculator will calculate things in radians for you. And you'll notice that on the top of your screen, if this is your little calculator, if you've got just a standard scientific one, it'll either have a little r or alternatively a little d above, just in the top corner. If you're in radians, obviously your numbers are going to appear a lot smaller, but have fun.